All right, good morning, everybody. Happy Wednesday. This is take 2 for me. I apologize if this gets posted a little bit later. I had the whole video pretty much complete, and then it just got deleted somehow. Technology, gotta love it. Can't live with it, can't live without it. But like we said, we're figuring this whole thing out as we go, so let's see if this one works. All right, doing a homework review video. And I was saying in the first video, which you'll never see because I don't know what happened to it, but we do have an assistant and she's still here. So if we run into any issues, Lucky's here to help us. Thanks, Luck. Keep up the good work. All right. So anyway, homework, condensing and expanding logarithms. All right, so we're gonna go through these properties and hopefully it makes some more sense, all right, after we go through the homework. I'm going to post a graphic organizer soon, all right, and it's got all the properties of the logarithms, and, you know, there's one new one, the change of base formula. It looks like this, all right? We want you to try to fill that out, okay? And the change of base formula, I'll show you how to do that. That's a new one, all right? So we can actually start with that really quick, all right? So change of base formula. All you have to do, our assistant is leaving us. Oh, she's gone. See you, Luck. Thanks. So back to change of base formula. All we have to do is we can actually evaluate this logarithm. This is just a general case, but we just have to take log of a, in this case, log of a divided by log of b. All right, remember the common log has base 10. Okay, when we don't see a number here as the base, we just assume it's the common log, and then we would just use our calculator to divide that, and it would give us a decimal. All right, so just remember the base goes in the bottom, think basement. All right, so that goes in the denominator. Your other number or variable, usually it's a number when we evaluate it, will go in the numerator. Okay, so that's change of base formula. Looking at an example right here, all you would have to do is take log of, well, 32 is the number here, the bigger number, that's going to go in the numerator. So log of 32 divided by log of 7. All right, and this is the common log. So the base went into the basement in the denominator. All right, and then we would encourage you to download that app, Calculate 84 app, if you haven't already. It's basically the same as the calculators we use in class, and it's just on your phone. It's a free app. So you'll need that for the change of base formula. You're going to just type in log. Okay, so log of 32, close your parentheses, divided by log of 7. Okay, so log of 32 divided by log of 7, and it gives you a decimal, which we can round to the nearest thousandth usually with log, so 1.781. 1.781. All right, so that's all you got to do for the change of base formula when you run into that, all right? Didn't want to throw too much at you yesterday. I knew we had a lot of new topics for you guys, all right? But this property sheet will be posted shortly, all right? And you'll see the change of base formula on there. So that's the only new thing for today. Besides that, we're going to keep practicing with our properties, all right? And want to go through the homework with you real quick. Okay, so with the product rule, remember, we're just going to turn multiplication into addition, all right? So log base b, for this general case, log base b of m plus log base b of n. That's it. All right, so if we look below here, this is a product rule. Okay, we see addition, which vice versa. The opposite's also true. We can turn this addition right here into multiplication. So the bases are the same, log base 7 of 9 times 4. Okay, which we know to be log base 7 of 36. Final answer. All right. And then quotient rule, well, division, what does that turn into? log base b of m. You're right, division turns into subtraction. Minus log base b of n. Okay, that's just your general scenario there. All right, and there's an example of this one right here. Okay, we see subtraction, so log base 2. So we turn subtraction into division, 80 divided by 5. All right, which really is log base 2 of 16, and we can leave it like that. All right, and then the last one, power rule is not too bad, really. All you have to do is just take that exponent and bump it to the front. All right, so it would be n times log base b of m. All right, so those are your general scenarios up there with your 3 rules. All right, and I'm going to go through the odds here. Now we had some questions on number 3. All right, so let's look at number 3 here. We see 1/2 times log base 3 of 81. Well, I don't see any addition or subtraction going on here, so it's really just power rule being tested. We're going to move that 1/2. I'm going to move that 1/2 up to the exponent. So log base 3 of 81 to the 1/2. All right, log base 3 of 81 to the 1/2. Well, if you remember our fractional exponents, when we raise something to the 1/2 power, so 81 to the 1/2 power, it's just 9, because it's the same as taking the square root of 81, which we know to be 9. All right, so that's as far as you could really simplify this one. You would say log base 3 of 9, and we can leave it like that. All right, so that's just testing power rule. All right, number 5 here, we have a little combination going on. We definitely have some power rule. Okay, we can move that to the exponent, and we can move the 3 up here as well. And then we have some product rule going on as well. So we have an addition, which we can turn to multiplication. So let's do one step at a time. Log base 5 of x to the 7th. I moved that 7 up to the exponent, plus log base 5 of y to the, well, it was already 4. Now we're raising a 3 up there. That's our power rule for the exponents. We need to multiply those. So we really need to recall some of those exponent properties and laws as we work through these, logarithm problems. All right, so that's going to give us y to the 12th. And now last step is turn addition to multiplication to condense it. So log base 5, and we're just going to write our variables next to each other. Of course, 6 feet apart, all right? Keeping our distance here with the variables. X to the 7th, y to the 12th. That's your final answer. Okay, moving on to number 7. Number 7, we have some more stuff going on here. Okay, we have subtraction and addition. So take it one step at a time. Log base 4 of x to the 7th divided by x squared. Okay, because that's going to turn to division. And then we'll leave this one out here for now. We'll take care of that next. Okay. And we also have a power rule going on here as well. So we know when we divide, we subtract exponents when we divide with the same variable. So that's log base 4 of x to the 5th plus log base 4 of x. Once again, we're going to multiply those when we use the power rule. 3 times 4 is 12, so we get x to the 12th. And our last step is to combine these once more. Log base 4, and then we're going to add those exponents now with the product rule. When you multiply, we're turning this addition into multiplication. When we multiply with the same variable, the same base, we are going to add the exponents. So final answer, log base 4, x to the 17th. All right, so that's the whole front. Hopefully you didn't have any issues on that, or hopefully this clarified it a little bit. All right, and now moving on to the back. Here's number 9. It says condense, then use the change of base formula. So here's where we see that change of base formula again. All right. So I'll show you how that works here. This is a simple subtraction to division. So log base 9 of 35 over 7. Okay, which is just log base 9 of 5. All right, so you can leave it like that on your homework. That's all we asked you to do. But if you were doing change of base, it's good to practice it. We would turn this into, well, think of it as it's always going to be turned into a fraction with log over log with the common log base 10. You don't have to write 10, we just assume that. Okay, and the 5 here is going to go in the numerator and the base goes in the basement down in the denominator. Okay, so that's log of 5 over log of 9. All right, so that would be your change of base formula. You'd pop it in your calculator. Okay, you'd go log of 5 divided by log of 9. And it'll give you 0.732 if we round it to the nearest thousand. All right, so that's your change of base formula. Number 11. Number 11 here, we have another power rule. We're going to move this up to the exponent, so log base 4 of 8 to the 1/3. All right, plus log base 4 of 15. All right, so let's simplify this. Remember, fractional exponent here again. Raising to the 1/3 is the same as taking the cube root. So if we take 8 to the 1/3, that's just going to give you 2. All right, so this is going to be log base 4 of 2 plus log base 4 of 15. When we combine these, we're going to get log base 4 of 30. Okay, which you could then go into change of base formula and evaluate that log of 30 divided by log of 4. All right, whatever that was in your calculator would be your final answer, but you can leave it just like this as well. Okay, and then last couple here, expanding. So once again, take it one step at a time. Log base 8 of m. Now, it's multiplication, so remember, multiplication turns to addition, so I'm going to go plus log base 8 of n squared. All right, and then last step here, we have a power rule going on. We got to bring that 2 out front. Just for the second part, still keep log base 8 of m plus 2 log base 8 of n would be your final answer. All right, and then let's see, 15 and 17, last couple. All right, here we go. So I would combine these first. I would actually distribute this power rule going on in the exponent. Log base 2 of a to the, we multiply with the power rule, so a to the 15th, b to the 6th. Now we can expand it, all right? Now we can expand this as log base 2 of a to the 15th plus log base 2 of b to the 6th. And last step, we would use the power rule to bring these out front, these exponents. I'm kind of rushing through this just because, you know, the Wi-Fi right now is spotty at best, so I want to make sure this video gets uploaded for you guys. All right, but that's the great thing about technology is you can pause this video if it's going too fast for you, and always rewind or rewatch different parts if you're confused. All right, so there's your final answer here once you use the power rule and bump those exponents out front. Last one here, we have a similar situation where we have to use our power rule. Oh, and our assistant's back for the last one. Thanks, Lucky. All right, so here we go, the last one. I'm going to say log base 5 of a to the 7/2. all right? Because when you take the square root, remember it's like raising to the 1/2 exponent, so we're just going to multiply those, get b to the 1/2 here, and now we're going to do the same thing we did in 15. Log base 5 of a to the 7/2 plus log base 5 of b to the 1/2. Bump these exponents out front. So we get 7/2 log base 5 of a plus 1/2 log base 5 of b. And that's it. All right. So hopefully this clarified a little bit of the homework for you guys. The solutions were posted yesterday with the homework, all right, but you might have been looking at a different language. But hopefully this clarifies it a little bit for you. Feel free to watch this video as many times you want. Shout out to Lucky. Thanks again for helping us, and hope everybody's doing well. All right, have a great Wednesday.